This week on Quality Digest Live, we examine how augmented reality is being used to improve test and measurement.
Plus, quality improvement does not mean copying Toyota. We'll learn why when we come back.
This episode of Quality Digest Live is brought to you by ETQ, the leader in quality management software solutions for identifying, mitigating, and preventing high-risk events through automation, integration, and collaboration. ETQ.
Welcome back to Quality Digest Live for August 23rd, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
That he is. And I'm Quality Digest editor-in-chief, Dirk Ducharme. Okay, well, this may seem self-evident, but new research shows, that caring bosses who help employees with their personal and work problems should not expect anything in return.
What? There's no payback for feelings?
Feelings. According to a study by Switzerland-based, this is a Switzerland-based business school, IMD, most managers believe that offering emotional support will benefit their company. Most employees, on the other hand, simply view kindness as part of their superiors' duties. About 75% of lower-level workers and middle managers reported receiving support from their superiors, but not one expressed a feeling of personal debt. So, as a manager, if you're going to go the extra mile, you shouldn't be doing it with any expectation. Otherwise, don't do it.
Yeah.
Because you should be doing it because it's the right thing or because it makes the workplace a better place, not because you expect to get anything in return, right? According to IMD researcher Ginka Togel, quote, "The fact is that managers do benefit from a happy team in terms of productivity and results, even without any additional displays of loyalty and commitment. Some manifestations of gratitude beyond that would be very nice, of course, but there's no reason for bitterness or hand-wringing if it doesn't happen to materialize." So there you go. I mean, it's one of those, it's motivation. If you're being a good manager, sometimes part of what that is going the extra mile, maybe taking a personal interest in employees, but not for expectation that you're going to get anything in return. It's more just it makes the workplace a better a better place to work. Otherwise, if you have expectations, don't do it.
It's not a what have you done for me lately kind of thing.
No, it's not.
Well, you know, Dirk, as you know, workers aren't the only ones wondering what have you done for me lately, as you just referenced in that past story. It turns out that when it comes to tried and true performance excellence strategies, top management may be asking the very same question. That's the theme of a story that we ran from Forbes this week titled, "Why Continuous Improvement May Need to Be Discontinued." Although even such a thought of such a thing might be anathema to some in the quality profession, this piece raises some interesting points and a few things I think that we can take issue with.
Sure.
I certainly did in the piece. In the article, Forbes contributor Ron Ashkenas, I hope he pronounced his name right, Ron Ashkenas contends that the policy of continuous improvement is losing steam as champions in Japan and the United States are finding limitations to the efficacy of CI methodologies. Ashkenas points out, and I think he's right on this, that a one-size-fits-all approach and a failure to look at how the big picture, may have hurt companies more than they've helped them. And I think it's fair to say that some of that can be laid at the doorstep of continuous improvement.
Sure.
That the people just kind of bolt on, and we're going to talk a little bit more about this in my story later, they kind of bolt on something that somebody else has done through the framework of benchmarking, and they think they're going to do it too, without really understanding how it fits into their particular culture.
Right, you can't just copy somebody.
Right, and again, we're going to find that out in the story from Trip Babbitt later on today. So I think that's fair. I think that what he's saying there is right, and that can be laid at the doorstep of CI. However, Ashkenas doesn't clearly differentiate the methodologies of which he speaks. For instance, in his opening paragraph, he writes about, and I quote, Six Sigma, Kaizen, Lean, and other variations of continuous improvement. Now, of course, for those of us that are in the field, we know that if you consider these very, very different frameworks and processes as variations on the same theme, I think your argument's going to get off the rails pretty darn quick. Yeah. And this becomes apparent when Ashkenas talks about how continuous improvement stifles creativity and innovation. Now, within the world of Six Sigma, we've heard that argument before, and you know, whether you agree with that assertion or not, you can have a good debate, and you can look at the evidence from both sides, I think, from companies like GE, Motorola, and 3M. There's plenty of evidence on both sides of that equation,
Sure.
whether it does or does not stifle creativity. Lean, however, I think is something very different. The whole intent of that methodology is to continuously improve flow and eliminate waste, and always with an eye on the biggest of the big pictures. It's a very strategic thing. It's tactical and strategic at the same time. Personally, I don't know if you have, I've rarely heard anyone say that Lean, in particular, stifles creativity and innovation of the companies that embrace it. So,
right, yeah.
Six Sigma, I've heard that, not Lean so much.
Yeah, it's kind of an apples and oranges thing.
Very much, and he's lumping them all together. So bottom line for me at least, continuous improvement means a lot more than Six Sigma, I think. And I think it's definitely alive and well in industry today, and you look at what's going on with Lean, I think you probably would agree. So for more information on this article or any of the pieces that Dirk and I are going to be covering on today's show, just check out the story links, which are below listed for your convenience, right down there below the video player screen.
That's right. Well, you know, Mike and I have been to a couple trade shows.
A few in our time.
And actually in this year. One of the things that we're noticing as we go from trade show to trade shows, we start to see trends emerging. You'll see certain things that seem to keep popping up in trade shows, particularly recently. And one of the most promising, I think, is the use of augmented reality in inspection. That was the topic of one of this week's articles, Usability Engineering, when the surface becomes the touchscreen. And in particular, this article talks about the merging of 3 technologies for inspection. And the technologies are scanning. In this case, they're talking about white light scanning, but actually any type of scanning could be used, laser scanning as well. Projection and hand gesture recognition. And it works something like this. Let's say you have an aircraft skin and you're looking at fasteners on the aircraft skin. You look in the slide right here. If any of you have seen an aircraft skin, you know it's full of fasteners. Tens of thousands, hundreds of thousands of fasteners, and those fasteners got to be precisely put in place. So how do you inspect them? Well, typically what would happen is you might use a white light scanner to scan the, if we can go back to that previous slide. You might use a white light scanner, such as they show here in this slide, to examine an area of the skin looking at the fasteners. And what happens at this point is the white light scanner, it goes out, it scans the fasteners, and it may compare them to a CAD model, or it may just compare the results to flushness and angularity that are programmed into the software. And then typically what happens at that point is that is presented on a monitor. And the monitor shows, oh, this fastener is in spec, this one's out of spec, so on and so forth. What happens at that point? Well, now the operator or the technician has to go out, has to find that fastener out of hundreds of fasteners that are within the field of view, and it's time consuming. He has to count over. I mean, literally this is a time consuming job. So one of the new things uses augmented reality to use a projector to actually project that scan back onto the skin. Now if we can go to the next slide, project that scan back onto the skin, and what we're looking at here is a photograph, and what you're seeing is the skin of a plane, and where all those circles are, that is actually a color representation of whether that fastener is in spec or not, projected right back onto the skin. So imagine that an operator is standing here right at the aircraft. He does the scan, and immediately the scan shows up. If he sees green, he knows that fastener is fastened properly. If he sees red, it's too deep. If it's blue, it's too high. And in this case, you can see also, if it has a little arrow like what we see on the right, then we know that that fastener isn't flush, not flush, but it isn't planar or isn't parallel with the surface. So now the operator doesn't have to go back and forth. If they see a bunch of green dots, they know they're good. If they see a red dot or a blue dot or an arrow, they know that fastener needs to be replaced. So that's one thing that's really speeding up. The other thing that is interesting, and according to the authors, it isn't quite being used yet, it's in development, but is use of hand gestures for control. Now we're familiar with this. If you've seen like the new Wii or the Xbox, they got gesture control where hand gestures can control the software, in this case a game. They're talking about using it. Look, you're in front of a camera already. You've got a camera that's scanning your work surface. Why not be able to control the software, maybe to set up another test program or whatever, maybe select other menu options without having to go back to the laptop or the computer and use a mouse or a keyboard. You simply make some hand motions, The projector projects your menu or whatever onto your work surface. You use other hand motions to select what you want, and you're good to go. Basically, the operator, once they set up, never has to go back to the computer again. And you're going to see more of this in user interfaces. User interface right now is really what everybody's concentrating on in hardware development. Hardware, for the most part, is becoming somewhat of a commodity. And what everybody's focusing on right now is simplifying the user interface. And this is just one way that is being done. It's pretty cool stuff.
Yeah. This is 8tree is the company, I believe. And
this particular article is written by 8tree. Yeah, but this kind of idea is being used in other places as well.
Well, I mean, we're seeing it, of course, in coordinate metrology. I mean, and that's really where that's where we met the 8tree guys. Was at the CMSC show in San Diego, and this article, I believe, appeared in this week's CMSC World e-newsletter yesterday.
Right, exactly. Yep.
So, we're seeing this more and more, and you're right, what you said at the top of your article, that these trade shows are a great place to go and really see how the technology is advancing. You know, in automotive and aerospace assembly, for instance, you almost look at this and you say, well, gosh, how could you not do this? How could you not use a tool like this? Because, you're talking about literally hundreds of thousands, million pieces, in some cases, fasteners in a plane.
And I think the critical thing is what I'm seeing, and I actually had an engineer from a large metrology company say, look, let's take a look at CMMs.
Yeah.
Honestly, once you get to the higher end companies, a CMM is a CMM, right? I mean, they all got about the same basic accuracy, they all work about the same way, and they know that. And so you'll see what they're starting to do is look at that user interface. They want to make this thing as easy to use and as efficient for the operator as possible, and there's a lot of resources being dumped into user interfaces right now. And in fact, I'm sure our guest today is going to talk about a little bit about that as well.
That too,
That's something Olympus has done as well. Is everybody's looking at how do we make a user interface, get it away so it takes an engineer to have to use the thing, and make it so a person can be trained up on it quickly.
Well, that's what I'm saying. You go to the trade shows and you start walking, and you just you automatically can start working with some of these touchscreen interfaces, and it's easy. I can do it.
Anybody.
Sure.
You can do it.
You can walk up there and start doing it. So it's pretty cool stuff.
Yeah.
Good. And again, articles right down there if you want to check that out on this augmented reality. Okay, another article we covered this week, more of a kind of a management piece that I like talking about often, is a piece from Trip Babbitt called A Question of Perspective. Again, by Trip Babbitt. It appeared in Tuesday's issue of Quality Digest Daily. And what Trip is saying here is that we need to change the paradigm in U.S. manufacturing, and that really we're still in the age, and you can argue this a little bit, but I think Tripp makes a valid point, we're still somewhat in the age of Taylorism. We're in the age of course, Frederick Winslow Taylor, time and motion studies from 100 or more years ago, where it was very much a top-down element, where management would look at what workers were doing and try to analyze how quickly they were doing it, how effectively they were doing it, and improve that. Because the system itself wasn't really questioned so much. It was the workers within the system that were questioned. And Deming, of course, flipped that on its side a little bit by showing with the red bead experiment that it is the system. And it's almost always a system that is a block, a bottleneck to flow and to performance excellence. And that was more of a holistic approach that really was, instead of being top-down, was much more bubbling up from the bottom, because we know the good ideas truly to improve companies often come from those that are doing the process, that are working the thing itself. So this approach really rippled through, as we know, Japanese industry in the 50s and 60s, and was brought back to America by Deming and others in the 70s. So I think what's happening since then, because we've come from there to now, is that many companies, I think, are now, and have been for a while, trying to copy Japan or trying to copy Toyota. And again, it kind of goes back to the story that I talked about a little earlier, where Japan does things, everybody thinks that they have to do it as well. Well, maybe not. I mean, maybe you should kind of do what works for you a little bit more than that, because copying doesn't really work, right? Culture change works. If your culture needs to be changed, and the culture that you're trying to copy is one that works for that culture, it may not maybe work so much for you. This reminded me of a piece that we covered last week on the show by Bruce Hamilton, and he talked about the element of bodies without souls in lean improvement. He talks about how companies will try to slap all of the different processes of lean onto what they're doing, check it off, do a checkbox audit, and just look at it and move on without really understanding the deeper part of it. It's kind of like they talk the talk, but they don't walk the Gemba walk. You know, I mean, they really don't embody what that is. I made that up. Yeah,
that's nice. Right?
Yeah, all talk, no Gemba walk. And that's what I think Tripp is talking about here too. Is that, you know, you can't just slap. You can't just, if you have a hole in the wall, just slap some paste over it and paint it and call it good. I mean, you may have to rebuild the wall, you know, if there's significant problems in it. And that's a matter of, I think, perspective. And again, that's where we kind of come into the paradigm shift here a little bit.
Well, I think that was one of Tripp's main points, is that you have to be willing to kind of buck the paradigm. The paradigm is, oh, you know, Toyota's doing everything right, so we got to copy Toyota. And he's saying, look, you know, sometimes you have to argue against doing that.
You do, and the great practitioners of Japanese, you know, lean, TPS would say that too. Shingo would say that. Ono would say that. That don't do what I do. You know, do what works for you, and that's a good point. He tells a great story. I want to get to this story because it was kind of cute. We talked about it with the Ludwig Wittgenstein thing.
Right.
Ludwig Wittgenstein was giving a speech and giving an address. Philosopher,
yeah.
Mathematician and philosopher.
Yeah.
And one of the people came up to him after the thing and said, "Boy, weren't those people dopes? You know, hundreds of years ago, where they looked up in the sky and thought that the sun moved around the Earth." You know, they should have known. Obviously, it's clear that the Earth was around the sun. And Wittgenstein thought for a minute. He said, "Well, yeah, but you know, do you ever think about what it would be like, what it would look like if the sun was moving around the Earth?" And the answer is, it would look exactly the same. It would be no difference. The point being that you see what your paradigm tells you you're going to see. You know, if you buy into something that deeply and you're not willing to investigate, and look at what you're doing, you're going to come to it. Well, it's just like anything else. I mean, if you come to something and you have an answer already in mind, any data set's going to be able to be twisted to prove that point.
Oh, and actually, continuing on with that that entire quote was actually a science historian, James Burke, I believe. The entire story on that is James Burke continues to talk about, you know, after he gives that quote by Lichtenstein, he says, okay. He says, think of it this way. He says, suppose that in science today, the current paradigm is that the universe is made of omelet.
Yeah.
He says, then all the astronomers are going to be going out there looking for signs of eggs.
Of course.
Because that's their paradigm. It's all made of omelet, so there must be egg out there. Yeah. And if they don't find egg, it's equipment failure.
Right.
Right? So you don't find what you're looking. You have a paradigm.
Yeah.
You don't find what you're looking for. It's not that your paradigm is wrong.
Yeah.
I must have made something wrong with my equipment, or my measurements must be wrong. It's not my paradigm is wrong. My measurements are wrong.
Well, because people don't trust the data. I mean, people don't. People, again, they come to something with an idea in mind of what they're going to find, and that's not a scientific approach. It's certainly not a good approach to quality and to improvement, I don't think. You know, one of the things that Tripp says within this, which I think was really good, was a really good point, was he said, you know, we shouldn't be, I shouldn't be, he took this on himself, which I thought was really interesting. He said, you know, none of us should be gurus and experts. We should never position ourselves that way. We should be lifelong learners. That's really a great point. Really well taken. Is we need to be lifelong learners in this industry that we're in, which is an investigative industry, just like science. We have to be lifelong learners and be willing to learn and figure things out as we go. And you know, Tripp, I think, did a great job with that. I would encourage you to read Tripp's story again. It's called The Question of Perspective. You can find it right below the player page, right down there. So check that out and comment on it. It's some good arguments, good debate going on the story as well. Okay, all right, we're going to move on now. We're going to go to our tech corner because we're as always going through the show quickly. This is a tech corner which we love doing. We have a guest in the studio with us today. It is from Olympus. It's their DSX Opto digital microscope, and Dirk and Rob Bellinger of Olympus are going to show it to you right now.
Well, thanks, Mike. Yep, I'm here with Rob Bellinger from Olympus, and we're going to look at the DSX 100, right?
Yes, that's correct. This is our Opto digital microscope, one of the members of the family. This is the 100 model. There's a 500 and 500i. The 100 model is specifically for a little lower mag range. This tool can go down to 5x, all the way up to about 450x. The system is meant for a little bulkier, larger samples, like circuit boards, medical device components like valves or circuitry for medical device.
And this seems to be mostly the market is circuit boards and medical devices.
Well, it has a broader range than that. Anything where you need a little lower mag, a little more working distance on a part, but still want to render high quality surface images at decent magnification, 500 or below, and you also want to take metallurgical measurements on the surface. So I'll cover a little about the tool. The interface, like you mentioned earlier, is simplified interface, meant for anybody to walk up and kind of use the tool.
And it seems consistent throughout this line, right? I mean, the interface really was intended to be something where it's fairly self-evident how it works.
That's correct. And in this line, the Opto digital microscopes, all the interfaces look the same. They have even tutorial modes where you can walk up and it'll guide an operator through the use of the tool, and with instruction windows, and they can get their images quickly and easily that way. Or even in the advanced mode, it's still very easy interface, big, large buttons, all touch screen interface here. Great for interaction to the screen, but also to break up the interaction constantly being on the mouse, and helps for ergonomics.
Okay.
So the microscope itself is an imaging tool. We have bright field, we can do transmitted light imaging, but this tool is a little unique because we also have the ability to do free angle imaging with the stand, and if you want to show that now, I have a live image on.
You showed me how to do this earlier, so I just loosen this knob, right?
That's correct, and you tip it off to the side so you can see underneath pads like this if it's important to see, the solder
okay,
line
so
underneath
we
the
can
pad.
see here I'm actually looking underneath.
Yep. Tipping at an angle.
So I can see completely underneath that, or I can come around to the other side.
Come around to the other side and you can see the solder.
This is what, 45
connection.
degrees each way?
45-degree angles, and we're capable of, angling at that range. You can mag in and do, image captures and all that kind of stuff.
Okay.
The interface for free angle is just a simple button push. We also have unique lighting options on this. This tool uses a ring light LED source. We can control the quadrant lighting, so we can get rid of some reflections off the surface. We can even rotate the lighting around. Some of the other adjustments in image processing, we have an anti-halation called wider. This is wide dynamic range. So you can see on a metal surface such as this, you have a lot of reflection coming off of the lighting. So the wide dynamic range can cut that reflection down and bring up the contrast around the outer surfaces. So similar to high dynamic range, but a little bit faster refresh rate. You can see the refresh rate isn't compromised on your image.
So a high dynamic range is where it takes multiple images at different lighting levels, is that?
That's correct.
Okay.
So a high dynamic range will actually take several images of exposure ranges and integrate them together. This system actually does it in a live mode. We can turn that on now, and you can see that it does similar effects to the wide dynamic range, but it gives you a little more texture. But there's a little bit of a lag on the image. Not too bad though, considering it's doing all of that processing on the fly. We also have just the straight contrast mode, where it brings the contrast off the surface. If you turn this off, normal microscope image would be like this.
And I understand also you have a way to show a whole bunch of different lighting conditions and just pick the one that's best?
That's correct. So the ease of use, again, if an operator doesn't want to have to deal with testing all these image processings out to find what works best, we have best image function. With this, you select what you're looking at, like a defects on the sample, and the microscope will go through the process of capturing the images at all the different lighting techniques, lighting image angles. So you can look through here. We have bright field, different segments of the LED. We have just straight bright field with wider, bright field with HDR. So you can get a quick image. You don't have to go through and check.
And then this is just a touch screen, so you would just select the one that you want.
Select the one you want and hit apply, and the microscope sets up all those settings for you. Above that, being low mag, you get a good field of view, but if you want to go larger fields of view, this tool has great stitching capabilities. So we can do a quick live panorama stitch, and if I hit acquire here, this is a manual stage. We do have a motorized stage option as well, but even with the manual stage, you can quickly move the stage to the side, and the software is going to stitch this all together for us.
Okay, so as we see on our Gage cam here, is as you're moving the stage, so it's actually capturing the image and stitching these together.
Stitching them together on the fly as I'm moving the stage. So you could
capture the entire piece if you wanted, just by moving the stage.
If I wanted to spend a little bit of time, I can move the stage over this entire part and capture an entire image.
And if you had a motorized stage, this could be
this can be done with the joystick, or the motorized stage you could actually touch and move the field of view with your finger, and it drives and stitches it together for you. The nice thing about this, you can use this image now. If I hit complete, I can also use this image as a map image, so low mag view to see where we're at and as a map image in this software. If I hit complete now, you're going to see our entire stitched image brought back out as a complete image view. So you can get large fields of view quickly, and what's nice about this is they're still calibrated. You can go in and do all your measurements.
And can you do 3D measurements as well?
Great question. So if we go back to our live image, let me move to an area that has some dimensions to this. So being an Opto digital microscope, we're not limited at this magnification. We don't have to reach over and turn knobs on the microscope or anything. It's an Opto digital zoom, so we can mag into a location such as this. And if we're looking at this, we'll see some in-focus data and some out-of-focus data. So three-dimensional imaging is required for something like this. We can select 3D on the screen here, and all we really have to do is set our range of focus. So it's all motorized control. With the microscope, I'll move to the very low point of focus. Once I reach my very bottom of focus and even slightly past it, I just hit the start button over here, and then I can move to the top of focus, which is to be the top of this little chip here, and we hit end. And once we have the parameter set, that's really it. You hit acquire 3D, and it's going to go through and build the three-dimensional image for us.
Now, while it's doing that, could you do 3D and stitching?
Yes, you can, especially with the motorized stage. Then you could even set up a large array of stitch area and set your top and bottom of focus range, and it could go through and stitch together all of it automatically for you.
Okay.
The manual stage is still possible. You just have to move it to the next position and then let it stitch through the Z range,
okay,
and then it would create an all-in-focused image for you. So once it's done and complete with the three-dimensional scan, you can see we have an all-in-focused image. You can see the low point and the high point, which is nice. But what are you going to do with an image after this? You're going to want to take measurements on it, correct? So we'll go to a measurement tab. Real simple workflow across the top of the screen.
Yeah, there's your. Yep. So you got imaging is your first step, basically measurements. Your next step, and reports.
Then create reports at the end. So now that we look at this, we can see there's a profile line on the screen here. This red line. The profile line is showing us the height data across the line of the sample. But we want to see it in 3D. We can hit a 3D button, render the image in 3 dimensions. Everything on the screen is, touch screen for adjustments, where you can see where you're actually taking this line profile across the sample. We can zoom in as well. This data, say you wanted to measure the height from the top of the solder joint down to the base point where it was, you get the information right down here. We have height, length, angles. We can export this to a data sheet. These data sheets can be exported out to Excel quickly and easily, but more than that, once you have the data, you just hit reports.
Okay.
So real quick to cover some of the other measurement functions. Profile measurements, this is for the three-dimensional. You can measure heights, lengths between points of heights. We also have geometric measurements, so measuring from center of circles to center of circles, or in between 2 line patterns or crossing line patterns. We can also measure volume on the surface. So something that comes off the surface or a void in the surface, if you want to know how much volume was removed or how much volume was piled over on the surface area, this software can do that, gathering the 3D data. Caliper measurements is a built-in tool for measuring line patterns, like 10 points across the line and averaging out those numbers. We also have particle measurement built into the software. So once we have our measurements and all the data, we want to create a report. Simple button press creates the reports for us in our built-in template. This template is modified to the customer's use, however they want it to look. We have our image, our line profile showing here, the measurement that we actually took on the line profile. What's nice is you can keep creating new pages, and say we want that big 3D image in our report as well. You just mark the area and tell it you want the 3D image. Maybe we want it when the height color shaded. We tell it OK. Now right in our report we have the three-dimensional image that's rotatable. We can zoom in and out, pan it around, get it the way we want it to look. Once we have it the way we want, our report is complete. We just export the report as a PDF file.
Okay. And I'm assuming also data can be data itself can be exported for use data analysis, that sort of thing?
Data analysis can be exported once we go back here to the data sheet. If you have a bunch of data points, you can export that right to Excel. It's probably the quickest and easiest way. Okay. We can also do Gage R R Studies built into the software. So you can do repeatability measurements between operators, standardized measurements, so GR&R is built in. We measurements is a big part of this. It's a metrology tool. So measurement reliability is important. So the software also has a built-in auto calibration feature. We don't have time to show that today, but it has that system comes with a standard you put on the stand, and the software does all of its own calibration. And that can be done as a check anytime the customer wants.
And the DSX 100 is what is the first, the smallest in the line? Is that?
Well, it's just the lowest mag range in the line. Yeah, the 500 and the 500i are the compound type microscopes. That they go up to
same
1,000
interface,
times mag
same
range.
interface basically on all of them.
Exact same software interface.
Software, okay.
Yeah, so it's ease of use is all there. Same interface that way. Different stand, different lighting techniques on the other scopes.
Okay. Well, Rob, this is the DSX 100 digital optical microscope. Do I have that right?
Opto digital microscope. Yep.
Two of the words right. Okay. All right, Rob. Thanks for coming
thank you
by
for the
and showing
time.
it to us.
Appreciate it.
Thanks.
Have a good day.
Yeah.
All right, thank you, Rob. Thank you, Dirk, for doing that great tech corner. Olympus's Opto digital microscope, as Dirk and Rob said, the DSX 100. Really good tech corner there, Dirk. And you're back. It was always fun to have Rob come down. Yeah. All the way from Reading.
He's practically a neighbor.
That's right. He is practically a neighbor. Practically the third man in the ring on these shows now. That's great. Thank you guys for doing that. Okay, well, that's our show for the week. But before we go, we'd like to thank our sponsor, ETQ. ETQ is a leader in quality management software, and they've been creating innovative solutions for the quality and compliance space for more than 20 years. ETQ is now pleased to announce their new mobile platform for the iPad. On August 28th and September 11th, they'll be telling you all about it in a pair of live webinars on the use of mobility in the QMS. During these webinars, ETQ will be demonstrating their groundbreaking new mobile auditing application. These are going to be great webinars, and it's going to be interesting to see what ETQ is going to do with this mobile app. So I encourage you to sign up and check it out. You can do so by clicking on the banner ad just below the screen or right down there. Okay.
All right. So thank you for watching our show again today. Thanks to Rob Bellinger from Olympus for coming by and showing us another piece of Olympus equipment. And that should be it here in smoky Northern California, where there's half a dozen fires burning toward us as we speak.
It's called August. Yeah,
it's called August. That's right.
But thank you all for joining us this week again, and thanks to ETQ too for sponsoring the show. And we're going to see you next week.
So long.
Thanks. Bye.
Thank you.